Hey there, this is Ian Perry, Project Supervisor at Candrone, and today I'm going to be working with stockpile assessments that we gathered using LiDAR data from the DJI L2. Now, sometimes when we're measuring stockpile volumes, we have to get a volume that is not a standalone pile in a conical shape. The pile might be backed into a box or another landscape feature, or we just need to understand how much excavation we can pull away from an active face. Today I'm going to be using a freely available software called CloudCompare to show you how you can get highly customized stockpile volumes to get your assessments as accurate as possible. So here you can see that I am in CloudCompare. Now I have a small sample of my excavation face. The larger point cloud I have already clipped out of here. Now, if you are brand new to CloudCompare, you have to know a few things. The first is that save often. Now, that is most easily done by clicking the folder structure at left, holding down Shift or Control to highlight the rest of it, and you will press the save icon, and you'll see that the saving takes place in the file format of bin. Now that's just fine. You can export a point cloud in a LAS file format later on, as you can see like so. At this point though, when we're working, it takes less space and is far faster to save. So I'm going to save this as a bin and overwrite the existing file. Now, if you aren't familiar with how to segment out the area that you want to focus in on, you'd simply click the point cloud itself, head over to this scissor icon. Now, this is the segment tool. You would engage this tool, and this menu comes up at top right, and you'd be able to highlight what you want and segment it in, or highlight what you don't want and segment that out. But I have already done that. So looking at this area, what I'm seeing is there is an excavation face here, and there is actually a road that traverses along the top of this excavation face. Now, we want to continue to excavate here and pull materials off of here, but we do not want to disrupt the integrity of this roadway. That is to say, we do not want this road to collapse. We have to ensure that as we're excavating this face, that we leave a 50-degree slope or less in the excavation face so that this road's integrity is preserved. By the way, in CloudCompare over at left, if you ever want to jump to a perspective like side or top or bottom, you simply can navigate these buttons at left. So what I want to do in this situation is model the excavation of material while preserving a slope angle of 50 degrees or less from this road down to the bottom of the quarry. So something that approximates this slope angle I am emulating with my cursor. So we want to figure out everything that we will take away while leaving this 45 to 50 degree slope in the excavation face up against the road here. So as you can probably tell, that's a pretty difficult undertaking. It's not like we're just simply highlighting around these standalone piles. We're going to need to cut into the face virtually. And so this is something we can do quite quickly and easily in CloudCompare. So the first thing I want to do is I'm going to highlight the cloud. And every time you execute a function in CloudCompare, you do have to click at left to highlight the item that you want to work on. Otherwise, these tools, they will be grayed out. So we're going to highlight this cloud, and I'm just going to rename this. It might be a little bit easier for me. Now, first thing I'm going to do is I'm actually going to trace a line where I think roughly the edge of this road will be when this face has been excavated away. So I click and highlight the cloud. And the next thing I go up here to this trace a polyline by point picking. I'm going to engage that tool. You can see the toolbar comes up at top right. Now I'm just going to click onto the cloud. I'm left clicking at this point. Now I've started to trace a rough line. I'm actually going to restart. Now probably best to just trace a straight line more or less. So I'm just going to pull this across like so. Now, if you want to pause at any time, you can right click and pivot around and look at what you've done. Now, if you make a mistake, you do have to restart. So I would go up here and I would go reset current polyline. That's how you can restart tracing a polyline. So I'm going to go back onto the cloud. Let's say I pause by right clicking, pivot around, click this plus sign to continue on your way. But in this case, I'm just pulling a straight line right across the top, right clicking. Yep, got what I need. I'm going to click this check mark. Now what you see here is it's created a polyline layer in the tree at left. Okay, so that just basically demarcates roughly where the edge of the road will be, where it will start to slope at 45 or 50 degrees down to the bottom of the quarry, all right? So now what's going to happen next is I'm going to want to create a plane at 45 or 50 degrees from that reference, from that polyline I just created. So I'm going to highlight the polyline and I'm going to go into Edit and I'm going to go to the option Plane and I'm going to simply Fit. So you can see this plane has been created, though it's not the shape that I'm looking for. So what I'm going to do is I'm going to right click this plane in the menu and I'm going to click on Edit. And so what you can see here is I can bump out the height in this case. There you have it. So this is the feature that we're looking for. Now it's actually orientated the wrong way and it's not sloping to the angle that we're most interested in for preserving the integrity of the road as we excavate this face. So we need to do a few things. First thing I'm going to do is pull open this Edit menu again and see it's only sloped to 21 degrees. I'm going to slope this to 45 degrees. So now it's a much steeper slope, but it's actually turned around. We need to rotate this 180 degrees. So to do that, again, keep this highlighted at left and I'm going to go into Edit and I'm going to go into this menu, Translate and Rotate. Now up here at top right, you can see the menu. What we're going to do is we want to rotate about the Z, right? So you can select this. I'm going to keep Translate Z and Translate X highlighted. And you can see what I'm doing now is I'm able to actually spin this around. Now this is left clicking, right? Now if I right click, I can actually pull it forward as well. But maybe I don't want to do that. So I can just disengage this Translate X. And now what I'm simply doing is with the left click, I'm rotating about the Z axis. And you can pause this at top. So now you get your pivoting capability back and you're viewing this. So what am I doing? I'm looking at how this plane intersects the edge of the roadway with respect to that polyline that we first created as a reference. And I'm going to pull this back forward a little bit. So I'm going to unpause the tool and I'm going to re-engage this Translate by the X. And I'm pulling this along with the right click. So we're getting that to sort of sit snug against that reference polyline. And we're going to pause again, look around at that. I think I'm really happy with that, right? So from the front, you can see what we've done. We've created a 45-degree angle downward into the excavation face up against the edge of this roadway. So I'm quite happy, and I'm going to check that to finish it off. So what do we have? We've just created a plane. That's a really great start. So we have the angle that we're looking for. Next, I think we want to do is do the same thing with respect to the bottom of the excavation. So I'm going to do another reference polyline. So I'm going to highlight the cloud and I'm going to go back up to polyline tracing and I'm going to, from a nadir or a straight up and down view, I'm going to click along the bottom of the quarry, basically where the machine would start to excavate. And I'm going to right click to pause. I think I like that. That's adhering to ground level. So I'm going to click the check mark, and now that is down here. All the new layers always accumulate beneath. That's how you know where your layers are. Now this is a great time to save, right? You can lose work in an instant and you become quite frustrated. So I'm going to highlight everything and I'm just going to overwrite this demo bin file. I'm going to say yes to that. So now if this crashes, I don't have to go back to an earlier or previous step. So with this new polyline along the bottom of the quarry, I'm going to create another plane. So back into Edit, and I'm going to fit a plane there. I'm going to right click and head into that menu. Now you can see that that plane is riding at an angle of about 0.8 degrees. I'm fine with that. We could take it down to absolute zero. I'm fine to do that. But I also want to make sure that we have that plane protruding into the face so that it intersects with the 45-degree plane that we've already created. So I'm going to bump this out, maybe 20 meters, I think. And it doesn't quite make it. So I'm going to do just another maybe 10 meters there. So there we have it. We have a plane that cuts into the slope from the bottom of the quarry, and we have a plane that cuts into the slope at a 45-degree angle from the roadway up top. Now, if I was really fussy about this and I wanted those planes to sort of meet nicely in a geometric sense, I might actually just perform a little bit of a rotation there on that new plane. So I'm going to go back down to Translate Rotate, and I'm going to rotate with respect to Z. And that's a left click, and you see how I'm able just to spin that back into its such that it's true with regard to the first plane. Now if I pause this, I can look and see how that looks. Looking dead on, you can't even see the new plane. From the back, yeah, I'm quite happy with that. So I will check that off. So got a couple of planes. What I'm going to be doing for my stockpile volume is I'm going to be creating a couple of sidewalls to complement these two planes to enclose essentially the volume of material that will be removed when we're finished. So here I have created two planes, one that extends into the face from the bottom of the quarry and one that extends at a 45-degree angle from above. Now we need to create a point cloud feature out of these two planes. So how does that work? Well, CloudCompare is really interesting in that respect, is that you can create a point cloud out of a vector surface or a mesh surface. So I'm going to take away that the second plane, so we're just focused on the first one. With this highlighted, I go up to Edit, I go into Mesh, and I go to Sample Points. Now, that number is looking to be about 100,000. I'm happy with that. I'm not going to need more than that number of points. And so just like that, we have created a point cloud. I turn off the plane itself. We have actually created a point cloud out of that shape. Now, if I turn on the second plane, I'm going to do the same thing. I'm going to go up to Edit. I'm going to go into Mesh. I'm going to Sample Points. 100,000. And there you have it. So the two intersecting planes that I created are now each their own point cloud. So what I can do here is I can actually get rid of those mesh files, as they're just kind of cluttering up my menu here. So I'm going to click on each of those and then right click to delete. And you guessed it, we're going to save. Now this is getting to a point where we don't need all this overlap. So what I'm going to do is I'm going to look at this scene from this side. I'm going to highlight the cloud we created at a 45-degree angle. I'm going to engage the segmentation tool, and I'm actually going to clip this excess out of here. See that? And I'm going to do the same with the piece up at the top. So unpause the tool, highlight all the cloud that you don't want, and segment that out. Now I'm going to do the same thing with the plane. Now, by the way, when you finish, you are going to want to click this check mark. Now, if I click this check mark now, it's going to create new layers out of the pieces I'm trying to trim off. And since they're just garbage, you actually click this little garbage pail icon, confirm and delete hidden points. So now all we have left of that 45-degree plane is the parts of the plane that we're most interested to measure against. I'm going to do the same thing with the plane I created from the quarry bottom. So highlight that feature, engage this segmentation tool, and I'm going to clip that out. And I can probably do the same here at the front. So I have to actually close the tool to highlight different clouds. I'm going to grab the master cloud, the cloud we captured with our L2, and the bottom cloud, and I'm going to segment those out from this point forward. We just don't need that excess data. All right, so now this is looking a lot cleaner. I'm going to save at this point too. So we've come a long way, and what we have here is a nearly enclosed volumetric space. We just have to create a couple of sidewalls. So to do that, what we're going to do is use a point picking tool, and that will allow us to actually enclose this volume at each side by clicking on the existing cloud features that we've created with the planes and that we've flown with the L2. So to start doing that, I'm actually going to highlight all three clouds of interest. And I'm going to go up to the tool Trace Polyline by Point Picking once again. Now the tricky thing here when you're picking points in a point cloud is ensuring that you actually pick the right points. So you have to pause and really pivot a fair bit. And I'm going to start, make it easy on myself. I'm going to start here. So down I go. And I pause to pivot around, make sure I'm actually getting what I want here. I've decided I'm going to restart. So from here, right-click to pause, pivot, make sure you have everything you want and no more. Reorient the cloud. Press the plus sign to continue. Pause. Now I'm going to traverse up onto the top cloud that I gathered with my L2. I'm going to press the plus sign, and I'm going to start traversing up the excavation face. Right-click to pause, reorient. The easiest way to do this is to click on the points against the horizon. If I click like this, it's way too easy to grab points that are in the scene further on down. So pivot until you're actually looking at points against the skyline and continue on your way, tracking the topography of the point cloud from the side. Now, I did make a little mistake there. I'm not going to worry too much about that. I'm just going to continue on for the purpose of this demonstration. Right-click to pause. Pivot. Look at points against the horizon. Continue on. Do so until you close off the polyline that you have created. Right-click to pause one more time. Make sure that everything has been captured. Press that check mark. Now, if you turn off your top cloud, you can see you've created a sidewall. Let's do the same thing on the other side. This will be the last wall we have to create before we have a fully enclosed volume to use for a volumetric analysis. Turn that top cloud back on. Highlight all three clouds. Engage the tool Trace Polyline by point picking. The more you pause and pivot, the better your result is going to be. Clicking exactly the points that will enclose your volume. All right, with the second sidewall traced out, I press the check mark, turn off the top cloud, and there you can see the second sidewall of my excavation face. So now what am I going to do to create these sidewalls? Now, this is another step we have to introduce because we haven't looked at this quite yet. So these new polylines, 1 and 2, I'm just going to rename these quickly to make things clear. So I'm going to call this sidewall 1, and this is going to be sidewall 2. I'm also going to rename the clouds. Just double click in the menu to do so. So I'm going to say bottom cloud. And up here, this is the back cloud. Might as well call this top cloud. Now we have a couple of polylines left over from the very start. I'm not concerned with keeping those, so I am going to delete those polylines. And I'm going to save. All right, so with the first sidewall highlighted, I'm going to go up to Edit. Now I'm going to go under Polyline, and I'm going to sample points. Just like we did with our planes, except we find this menu item under Polyline instead of Mesh. Now I'm going to use that 100,000 number. That seems to be a good number. So what have I done there? I've actually just sampled the polyline itself. So if you zoom in, you can see that these are points. Now using these points, I'm going to create a mesh. It's going to be the Delaunay 2.5D. Now we have to make sure that we consider the length of the longest side that we're dealing with in this polygon shape. So I'm going to just set this at 20 and hope that I get full coverage. That might be a little bit long, so I'm going to delete that. I'm going to try that again. I've created a mesh out of that polyline. Now I have to create a point cloud out of that mesh. So with that mesh highlighted, go back into Edit, go back into Mesh, sample points as we've now done several times before. And you can see we've created a point cloud and the sidewall we need in order to finish this enclosure for our volumetric analysis. We just go over and do that one more time at the other sidewall. So I highlight that, I go into Edit, and I go into Polyline, sample those points. 1,000 is fine. Highlight those sample points, go into Mesh, create a two-dimensional plane. There it is. Highlight that, go into Mesh, sample points to 100,000, and there you have it. So now I have created two side walls, a back wall to 45-degree slope, and a bottom with my original cloud on top. So we have created a perfect enclosure. Now, one more thing before we actually analyze that for volume. We have to merge those new clouds together. So here you've created 4 new clouds: bottom cloud, a back cloud at 45-degree angle, and 2 side clouds. And we want to save this again, but I do want to clean up things a little bit just to keep it orderly. So we can actually delete these sampled polylines. Those were just temporary files to get us going. So I'm going to highlight that, I'm going to delete that. Highlight this, delete that. I'm also going to delete the sidewall tracings. Just make sure you are deleting the proper files, as it would be a shame to have to start that process over. So I should be left with 5 files for each point cloud. Now I'm going to highlight the 2 sidewalls, back and bottom, and I'm going to go up here and I'm going to hover over this, merge multiple clouds. So that is a merge function. Now it's going to ask me, do you want to create an index of the original clouds? I'm going to say no. So what have I done there? If you see, I can just turn this off as a single layer. I only have 2 files left, my top cloud and my bottom cloud. So now I'm ready to do my stockpile analysis. Now you can see here that I actually still have some excess, like along the top. Now I would, in an ideal world, trim that up to make this as truly representative as possible. But for this demonstration, I'm not going to worry too much about that. How do I get a stockpile assessment, a volumetric assessment from these 2 clouds together now? So as with everything, highlight both the clouds, go into Tools, and hover over Volume. You're going to see this option, Compute 2.5D Volume. Now you have this menu. You have to decide which cloud will be the ground and which cloud will be the pile. Now that's pretty easy for us, as we have created this back cloud as the ground, and we have the top cloud as the top. It's very important that we interpolate the empty cells, because what this is doing is creating a raster file, a raster representation, in order to subtract top from bottom, or bottom from top. Now, one more thing you can alter here is the resolution of the raster data that this creates when they do subtraction. I would say 1 meter is fine at this point. So with that, you calculate. Now I can see here added volume is 1,295 cubic meters. Now, how do you do just a sanity test and make sure that that's in the ballpark? Well, I'll show you how you can do that. So highlight the layers and go over here and click on point picking. And you can bring up this ruler option, top right-hand corner. So you can pull a length, and you can see that that's 31 meters long. Now you can pull height. You can see that that's about 5 meters long. And you can pull a length. It's about 8 meters long. This is not going to be a perfect geometric shape, but it's just a rough idea. So what's 8 times 5 times 31? I'm going to pull out my calculator app. 8 times 5 times 31. That's about 1,240 cubic meters, and that's almost exactly what this volume analysis showed us. So again, highlight both the clouds. Go up to Tools, go to Volume, Compute 2.5D Volume. Make sure that you highlight the back cloud first, and then the top cloud. Make sure that you interpolate holes and update. And you can see here we have 1,295 cubic meters of volume. So there you have it. You can export this if need be and give this report to your client. So just in quick review, we had a stockpile that looked like this when we started. But someone came to us and said, we need to understand how much volume will be taken away if we cut into this slope at 45 degrees and take out everything to the left. The 45-degree slope is intended to preserve the integrity of this roadway above so that it doesn't collapse when machines or trucks drive across it. So we created a plane that cut through at 45 degrees. We created an intersecting plane from the bottom of the quarry at 0 degrees, and then we created 2 sidewalls in order to completely enclose the volume of interest. And this is what we were left with. And we used the volumetric tool in CloudCompare to understand the volume of this being about 1,200 cubic meters. If you like this video, check out our YouTube channel and go to candrone.com. Don't hesitate to reach out to us with questions about this process or any others.